Since a titration using an indicator is an imperfect tool, after all, a indicator will undergo its change over not a precise pH but a pH range. Things aren't perfect. The reason it still works really well is because oftentimes as you go through that rapid change in pH, the equivalence point, things are happening so rapidly, the pH change is so steep that it's okay to have an indicator which changes its color over a slight range. Since it's an imperfect tool, though, we have separate terms for each, and we have the equivalence point and the endpoint. Let's go ahead and come up with a scenario where you could try to explain each. And this is the kind of thing that might show up on an AP exam. So you got a scientist from NASA. He's going to find the pH of a strange pool of liquid that was returned from Io, which is one of Saturn's moons. Comes back to Earth, and they use a pH meter, and they find that the pH of that weird solution is 0.51. That should probably be confirmed by a titration to make sure that it's going to work out. And he will. He'll confirm this by titrating that strong acid with a strong base. And he'll calculate that the hydrogen ion concentration is 0.309 molar, which is getting to the heart of things. The equivalence point is when it's exactly going to be stoichiometrically equivalent, and that's determined theoretically. The endpoint is when you actually do a titration and when you measure it experimentally and do not expect a perfect match. So it's 0.309 molar. And then he assumes it'll take, therefore, 20 mils of sodium hydroxide of the same molarity to neutralize 20 mils of the unknown liquid. However, when he performs the reaction, it took 20.3 mils of the base to neutralize it. Explain. Well, it's simply that there's some experimental error inherent in a titration that uses an indicator. And here's how they explain it. The NASA scientist calculated the equivalence point. That's how he came up with his 20 mLs. But he measured the endpoint and got 20.3 mLs. He may not have made any experimental errors. The pH change of phenolphthalein is 9.5 to 10.5, so it's going to take a little bit more to get up to that pH. This is strong acid, strong base. It's supposed to change at 7.5. He should have chose either a better indicator, which would have helped a little bit, or he should have used a pH meter, and that would be a nice way to do it. So that's the simple difference between equivalence point, which is theoretical, and endpoint, which is experimental.